So we were in Seattle area for 2 years while I was in high school. And while we were up there, Mount St. Helens erupted. And I was absolutely intrigued with the idea that a volcano, this amazing natural force that we have no way of possibly ever influencing or controlling, could be so powerful, creating new land on Earth, but destroying at the same time. I mean, it was really spectacular.
All right, you're listening to Hawk Talk. I'm here today with Lori Glaze. How are you?
I'm doing great. Thank you.
Yeah, thank you for coming on. So to start, I assume the day you're born, you end up in the delivery room and you just go, hey, this is boring. We should probably explore up there and just go to space because I'm done with Earth already. Took you about a
Of
day?
course.
Yeah, perfect. So yeah, take me back. Where are you originally from?
I was born and raised in Texas, North
Uh-huh.
Texas, mostly Arlington, Texas, and Dallas-Fort Worth area. I'll tell you from the beginning, I was always a math and science nerd. I always loved math and science, but I didn't actually know where I wanted to end up.
Uh-huh.
I didn't have this vision. I know a lot of folks that work in the space industry, knew from the day one that they wanted to do something
Yep.
with space. It wasn't necessarily me. I was intrigued by space always, but
Yep.
not necessarily as an end goal.
And
but,
what was it about math and science? Why was that intriguing to you?
I don't know. I love the way that math and science work together. I will tell you, I'd always liked math, and just the process, like particularly algebra and calculus were my favorite.
Uh-huh.
The ability to take just a few simple rules and then to expand those and be able to solve really complex equations and problems. And I really enjoyed that. And then when I started taking physics classes and I realized that, calculus was invented in order to solve these amazing physics problems, it just all came together to me in my
Yep.
mind that what a beautiful world we live in, that all of these amazing physics around us can be described by mathematical equations.
And did that start, like, were your parents scientists or in mathematics, or was...
Actually, both of my parents were engineers.
There you go.
My dad was an engineer. My mom was an engineer. My stepdad's an engineer. My brother's an engineer. I come from a whole family of engineers. I'm a scientist,
Yep.
so I was kind of the odd one out. I'll just take a little aside here. My mom was an enormous influence for me and a great role model.
Mm-hmm.
She got her engineering degree, aerospace engineering. They were both in aerospace engineering, just to be clear. So that
Yep.
was kind of an edge there.
Yep.
But she got her degree in aerospace engineering from Kansas University in 1960, meaning she graduated high school in 56, went to college, decided that's what she wanted to do. One of only, I don't know, fewer than 5 graduating females in that class of 1960, of hundreds of men,
Yep.
engineers that were graduated from KU that year.
What did your parents do with their degrees? Where were they working? Were they designing airplanes? Like, what were they doing?
They worked for a Navy subcontractor in the Dallas-Fort Worth area in Grand Prairie. It was called Lang Timco Vought, or LTV, later Vought Corp. And they were working on designing Navy planes and things like that. But what's interesting about that, and part of what kind of gave me a little bit of the space bug, is they both, at certain periods in their career, were put onto some subcontracts to support design of the Space Shuttle, NASA's Space Shuttle. So they each did some design work on the Space Shuttle. My mom did a lot of work on the thermal tiles that were on the leading edge of the Space Shuttle.
I'll never forget the story of, I forgot which president it was, but put his hand on the tile and they had to replace that whole panel because they weren't sure where his hand actually hit.
Yeah. Don't touch flight hardware.
Yeah, exactly.
That was kind of an intriguing piece for me, having that little kind of peripheral touch of the space program and the early days of the Space Shuttle before it flew. So that was pretty cool.
And were they able to share that? Like, did they actually tell you about their designing this thing to go to space?
A little bit.
Okay.
I was young at the time. I mean, when Space Shuttle flew, I was in high school and college. But when they started working on it, I was probably in junior high and that sort of thing. And I wasn't really paying that close attention to what they were telling me. But I knew what they were doing. I knew it was really cool. At that time, there was a short period of time my mom worked for Martin Marietta and was doing some contract work for them when she was doing the thermal protection work. So it was pretty cool time.
And so you mentioned, again, you're into math and science as a kid, but or were you like, what were your main interests? Did you think you wanted to be a scientist when you grew up when you were 7? Like, where did your interests lie when you were sort of a younger kid?
I don't think I even realized that scientist was a career option, I'll be honest. But like I said, I knew I liked math and science. I'll tell you that one of the key events in my life that did kind of set me on my career path. I was for a short period of time. Again, my mom got loaned up to Boeing for a couple of years, so we were in Seattle area for 2 years while I was in high school. And while we were up there, Mount St. Helens erupted, and I was absolutely intrigued with the idea that a volcano, this amazing natural force that we have no way of possibly ever influencing or controlling, could be so powerful, creating new land on Earth, but destroying at the same time. I mean, it was really spectacular. So when I went off to college, I knew I wanted to do math and physics classes, and I did that. But I also took a volcanology class because I was just interested. I thought it was cool. And that was an amazing turning point. I was fortunate enough to take a class from still one of my colleagues, one of my mentors, Dr. Stephen Self, who is an amazing physical volcanologist. And through taking that class as an undergrad, he says, would you like to stay on and do a graduate degree, do a master's jointly between physics and geology? And that was kind of the point where I thought, hey, I could maybe do this and be a scientist as a career.
That's amazing. Isn't it incredible, like, that one person can make so much of a difference in your collegiate, career, or just your entire sort of upbringing? And
Yeah.
probably to them, I wouldn't say not high impact, but in some ways innocuous. In some ways, like, oh, I like this student. Maybe you should come and do more of this. Like, that's, probably the amount of thought.
Yeah. I mean, I had an interest in the physics part. He was a geologist, and he thought, hey, maybe this young student here who has an interest in math and physics could come in and do some modeling work that he wanted done. He also had an interest at that time in using satellite images of volcanoes. But that was kind of a new thing, using weather satellite images to look at volcanoes. And it certainly was out of his wheelhouse, but he was very interested in it. And he thought, well, maybe someone with a more, math and technical background would be able to do that. So I came in, and it worked out really well. Like I said, we still work together and still collaborate.
That's amazing. And so you stuck on for your master's degree, and then did you stay on for your PhD too?
After my master's degree, I was a little tired of school and decided to take a break. So I got a job at the Jet Propulsion Laboratory in California, which was an amazing place to be at that time. The Voyager spacecraft were getting ready to fly by Neptune, and it was just pretty spectacular. So I went out to JPL for a couple of years. And after about a year out at JPL, I realized, I think that's where it probably really solidified that I really wanted to be a scientist for a career, and that if I wanted to be a serious scientist, I had to get a PhD.
The connection from volcanoes to space, because to connect the dots there. Obviously, I understand that there's also thermodynamics and other planets and things like that. But what propelled you to not study the volcanoes on Earth, but to actually go to JPL?
Well, so when I went out to JPL, I was actually still studying volcanoes on Earth. I went out there to work with a colleague on an idea for a satellite, Earth orbiting satellite that would look at volcanoes on Earth. So that was the whole idea behind going out there. But again, after being out there for a while, and I got to meet a bunch of planetary scientists that studied the planets in our solar system, and really began to learn a lot more about the volcanoes in the solar system. So, the largest volcano in our solar system is on Mars, Olympus Mons. You can put the entire chain of Hawaiian Islands just in the central crater of Olympus Mons. Realize that the most active volcanoes in our solar system are actually on a moon of Jupiter called Io. And then got really, really super intrigued with the volcanoes on Venus. Venus is our sister planet, almost the same size as Earth, very similar part of the solar system, should have formed from the same materials, and yet somehow they evolved really differently. We have, conditions that are very hospitable to life here on Earth. Venus, you can melt lead on the surface. Surface pressures, atmospheric pressures, like being a mile underwater. So it's not great for us. But it was a kind of place that we think volcanoes could still be active on Venus, but we don't know the answer to that yet.
Yeah.
And so I got really intrigued with that possibility.
Got it. And were you able to work on that at all while at JPL, or was that what you then went back and started working on the PhD side?
I definitely did my PhD working on some of that, but I was working on it out at JPL as well. I actually was working at JPL while I got my PhD. I stayed there throughout my PhD and was able to get my very first funded NASA research grant while I was out there, specifically to work on Venus.
And so I'm curious about Venus. Obviously, as you said, you can melt lead on the surface, the pressure and the temperature. What have we been able to do in terms of getting close? Like, have we been able to land anything on there, or is it basically we don't have materials that could withstand?
No, it's a great question. Actually, the Soviet Union landed on the surface of Venus several times. They successfully landed, but I will tell you the world record for survival on the surface of Venus is less than 2 hours because it is just so hot, and anything you put down there is going to heat up, and eventually the batteries will explode, and it's not great.
Yeah.
We're still working on technologies that can last longer on the Venus surface. So the Soviet Union landed several times back in the 70s and early 80s. The United States sent a probe into the atmosphere one time, and it lasted all the way through the descent. Sent a couple of small probes as well, and one of those actually landed and survived the landing. We've had a couple of orbiters around Venus, but we actually haven't had a lot of science from Venus, at least for the United States, for quite a long time. But NASA recently selected 2 new missions to go to Venus early in the next decade. And then European Space Agency also selected a mission to go to Venus with a U.S. instrument. So we're all going back.
Making progress. Nice. And so, so what was your PhD thesis, and what was the specifics of it?
So my PhD thesis was looking at volcanic eruption columns. So you can imagine an explosive eruption if you have in your mind's eye, whether it's Mount St. Helens or Pinatubo or some other big, massive ash and gas eruption. My thesis was really to develop a mathematical model that could describe how that gas and ash rises up through the atmosphere. So you say it comes out at a certain speed, and you've got so much material coming out at the vent, and it's so hot, some temperature. How high is that going to rise in the atmosphere? So being able to predict just how high these plumes can go, looking at the interaction of the gases and the ash, and then maybe condensation of the water vapor that's in there, and trying to better understand how these plumes behave. And so I did models of those plumes on Earth and on Mars and on Venus.
Had spent any time in the Guatemala volcanoes, by the way?
I haven't spent time in Guatemala. I've been really lucky as a physicist and a scientist working with geologists. I've been able to go on some pretty cool volcanology field trips. I've spent about a month doing field work in the Atacama Desert of Chile. I spent about a month doing field work out in Kamchatka of Russia, actually towards the end of the Soviet Union. So that was in 1991. That was pretty interesting. And a lot of field work in Hawaii. Which is a fantastic place to do field work, and Italy as well at Etna. So I've been pretty fortunate.
Yeah, I'm going in like 3 weeks to hike a volcano in Guatemala, so haven't been, but we'll see how it goes. Yeah. So you get your PhD. Did you stay at JPL after that, or did you?
Well, after I got my PhD, I actually came back to the East Coast. I had an opportunity to come work at the NASA Goddard Space Flight Center to do a postdoctoral fellowship. And that was, again, kind of a key moment for me because it transitioned me to the East Coast, where I still am out here. And I worked at NASA Goddard for a few years doing my postdoctoral research.
And where is that? Sorry, I know these. NASA
Goddard Space Flight Center is in Greenbelt, Maryland. It's just kind of outside what we call the Beltway, right outside Washington, D.C.
Awesome. And how was that transition and experience moving out there?
It was awesome. I'll tell you, it was kind of a big jump. JPL is a great place. I loved working at JPL. It's a very exciting place. And so coming back to Goddard was a big move. At that time, I had my first child, and our second one was close to on the way, and so it was kind of a big transition time for me to move out here. But it was great. I love Goddard. It's a wonderful place. It is really NASA's foremost science center, very focused on doing science. So it's a great place as a scientist to be surrounded by NASA's science programs.
I mean, as you said, you've been doing this for, I guess, now almost 40 years. Is that fair?
Mm-hmm.
And so,
Almost.
yeah, you said 91, so I assume a little before that. But so with that being the case, like, how have you seen the changes over the past 30, 40 years in terms of like the attention to space, the funding of space, the interest in it? Like, has it been, because you're in the right place, has it been pretty consistent and not a lot of hiccups, or?
Well, there's always little hiccups. I think that the interest in space is absolutely consistent. The public interest in space is always there. It's just such a fascinating world. Both on Earth and beyond.
Yeah.
And I think the human interest in space is pretty consistent. What changes over time, funding wise, is whether people are more interested in this kind of science or that kind of science. Is this a time when people really have a push for Earth science and really understanding and focusing on understanding our Earth? Or in sometimes it shifts a little bit away from that and more towards let's understand the solar system and the universe in which we live. So it kind of goes a little bit back and forth. And then we'll get to what my current position is, but it also swings back and forth a little bit between the kind of robotic space exploration and the human exploration side of the house.
Yep, that's
so that definitely also you see kind of ebbs and flows in those areas as well.
Yeah, that makes sense. And so that transition to Goddard, what was, when you stepped in there, what was your role? What was your sort of, main mission stepping in there?
Yeah, so when I stepped into Goddard, I was really kind of just out of my PhD and trying to establish myself as a scientist.
Uh-huh.
So really doing my scientific research, trying to write publications, papers to publish my research and get the peer-reviewed position and try and secure some NASA funding, some grants so that I could do my work. So I was really focused on just trying to build my scientific credibility. And I did that fair amount of focus on that for several years.
And how does that work in terms of like, is there someone at NASA that's just like, wait, we like what she's doing, let's give her some money? Like how complicated is that? And that's obviously, that is very oversimplified, but
NASA has a pretty rigorous competitive program for securing funding for doing research. And that includes scientists at universities, but also at the NASA centers. NASA defines certain research areas. And if you would like to get funding in one of those areas, you have to write a pretty extensive proposal. It has to be very detailed. It has to really sell the idea of why this is the right research that needs to be done now. And you're the right person to do the research. And the costs are reasonable.
I was going to say, is the KPI for it, is it the impact on humanity? Like, what are they looking for in terms of like what they put funding towards?
Yeah, it kind of depends on each of the different programs. They're usually looking to really advance our scientific understanding.
Mm-hmm.
That's usually the key, right? How do we advance our state of understanding and our state of knowledge and move it forward? My background in planetary science, one of the key areas is we've got data from certain, all the missions that have flown in the past, robotic missions. We want to be able to demonstrate that we're using those data to really advance the scientific understanding, but then also take what we learn in those new studies to help us design the next round of robotic missions. And so if you're moving that process forward, that's really one of the key pieces.
Got it. And so you wrote a lot of papers, we're working on funding. It sounds like you got your funding and got to move forward with the project. What was the first thing you got funded for?
Well, the very first thing I got funded for was my Venus research, which was when I was out at JPL. But when I was at Goddard on my postdoc, I was really most proud of one of my first things I really wrote that I led and had a team was using some data from the Mars Reconnaissance Orbiter, which is one of our orbiters at Mars. I'm sorry, wasn't that one? It was Mars Global Surveyor. Make sure I'm correct. The laser altimeter that was on there, where it was measuring the altitude of the surface on Mars. And I wrote a proposal to use those data to understand the thicknesses of lava flows on Mars and then be able to model backwards what the eruption conditions were for those lava flows. And so it's kind of an esoteric thing, but it was pretty cool.
Interesting. And
I had a lot of fun doing it.
I would say, does Mars still have consistent volcanic eruptions?
It's not active today, as far as we know.
Yeah.
Mars is much smaller than Earth, so probably the interior is cooler, and it's not likely to have active volcanism today.
Yeah, awesome. And so, what happened next? You got to do that research. Like, was there ever like an overall mission in your head of like, this is where I want to get my career to, or is it more like, this is interesting, let's dive in?
It was more of a, this is interesting, let's dive in. And I talk to a lot of younger people these days who, they look at, where you end up, how do you end up in the position you are now? And it's like, I didn't aim for that.
Yep.
What I aimed for throughout my career was, I wanted to build my expertise in a certain area. And then instead of continuing to go deeper and deeper and deeper, what I tried to do was go broader. So if I had a new opportunity, something came along that was, somehow it's related. So I'm building on the knowledge I already have, but I'm always learning something new, trying to push myself outside of my comfort zone to learn new things. That's kind of where I find my sweet spot. Get comfortable and then try and get out of that comfort zone and learn something new. So I would kind of branch out into different areas. So I told you I started with explosive eruptions. I moved into looking at lava flows. So those are related, but just a little different. So what came next after my postdoc was I had a colleague that I had actually met at JPL, and he started his own business, his own scientific research company. Uh-huh. And I jumped ship and went and worked with him. And we ran that private company for about 11 years, where he was the president and I was the vice president.
And are those companies like are you working on grants from NASA and everything still, but to do it privately?
Yeah, that's exactly right. It was still NASA-funded research, getting NASA grants. We did a little work for the Department of Energy, where I, again, was kind of stretching my boundaries and doing some work teaching statistics to nuclear materials people, which was totally new for me. But it was fun. It was a great time. That was a fantastic period in my career.
During those 11 years, like, trying to see like what tied it together, how were you looking at that as a new learning experience? Was it that you enjoyed the idea of privatizing this, or what was compelling about that?
What I found interesting really was that I was learning how the whole business operated from end to end. Mm-hmm. I had been so focused on the science part. I could write a science proposal and I would get the funding and I'd do the science, I'd write the paper. Well, now I had to learn how to set up the contract with NASA. I had to learn how to do billing rates. I had to learn how to figure out, how much are the, benefits, if we've got health benefits and retirement benefits, and how does that calculate into how much we're going to charge our clients? And then how do you figure out what our overhead rates are? And how do you keep track of all that and work with the tax lawyers and try and make sure everything holds together? So it really was kind of soup to nuts all the way, really, because it's a very, very small company. My business partner, myself, and a couple other people, we had to really understand every single aspect of how that company worked. And that, to me, was, I thought, really valuable. In most times, if you're an employee somewhere and you want a computer, you just say, I want a computer. But if I'm managing the overhead account, I know what goes in, and I can determine what I want to spend it on.
So we have 300 people that work here. My laptop's 6 years old because I can't it's my own P&L. I can't bring myself to buy myself a new computer. It's so funny you say that because it's so top of mind. This thing's like half working, but I'm like, it works enough. I'm not spending the money.
I'm with you. I know. And it comes to the end of the year and you're like, do I give myself a raise? I don't know. I don't know if I want to take that. I can get more hours out of my grant if I keep my pay rate low.
So what caused you to move on from that?
The competitive environment for research at NASA has gotten more and more intense over the years. For that time when I was in the private company, my business partner and I had incredible success. I think we were very lucky. I mean, we worked really hard, but we were pretty lucky in our success rates. But I could see that the community was growing, the competition was getting stronger and stronger. And it became more and more risky to write those types of proposals. The good part is that you have a lot of control over your life when you have your own company. The bad part is if you have a few proposals that don't get funded, there's no salary. So it got pretty risky, and I had a young family. So at some point, I started talking to colleagues at Goddard again, at NASA Goddard, and was able to go back to Goddard as a civil servant. That was a lot of fun.
And what year was that you went back?
That would have been 2007.
Okay, got it. Were you doing similar research on your own as you went back to Goddard? Was there like a lot of similarities? It was just not running your own business?
Yeah, it was very similar research, but the opportunity at Goddard, what opened up there, again, I told you I like to always keep expanding something similar, but let's
and
learn
we're similar that
new.
way, and that's why it's compelling.
Yeah. So when I went back to Goddard, one of the main things I was interested in was developing new ideas for new robotic missions, which was something I didn't have the ability to do with a small company. But at Goddard, Goddard builds and proposes a lot of these robotic missions. And so it was a great new opportunity to get involved with mission concept design. And I was involved with a lot of mission concepts in that period. It was fantastic.
So mission concept, is the idea is you're putting together thoughts on what could be missions, and then NASA may or may not select them and be like, oh, that's something we'll put on the docket.
Yeah, it kind of took the little science grants and proposals that I was writing and put them on an Uber scale, right? Yeah. So you're writing a science grant proposal, you're asking for, $100K, $100,000. And I put in a mission proposal, we're asking for, $1 billion. Yeah. So it's a different scale. Yeah. So taking a science idea, really honing it, pulling together a team, working with big teams, hundreds of people, of scientists and engineers around, here's the science we want to get done. What kind of a spacecraft do you need? What kind of instruments do you need to do the science? What kind of operations concept do you need in order to get the measurements that you need to answer those questions? And designing the concept and then writing a proposal that is compelling and can convince somebody else that this is a great idea. That was really a lot of fun. I enjoyed working with those teams a lot.
How do you deal with maybe less you because you understand how it's all made, but your team when you do all this work for a proposal that doesn't get selected? Because imagine the work that goes into that. What percentage of them get selected?
Very small.
Yeah, I've got to imagine it's
I don't know. I can't do the math fast enough, but it's such a small number that actually get selected. One of the big proposals we submitted, I think, at least 3 or 4 times, and none of those got selected. It did eventually get selected after I left, but there would be, for example, 28 proposals get submitted, and only one of those actually gets selected to fly. Okay. It's very, very competitive.
3-4%.
And you put in hundreds and hundreds and hundreds of hours of your time. It's an enormous amount of work, and so it is disappointing. But again, just the working together with those teams was incredibly, I'm very, very proud of the work that we did.
Yeah. The actual process is enjoyable. The work, the research that goes into that's enjoyable. So it's not like, well, that was worthless. Like it's more like that was actually great. Now let's do the next one. And eventually these will get selected.
And what we do is you take each one and you get the feedback and you say, okay, how can we make it better? We're going to do it again. We jump right back in and let's build it better. So as I said, one of the ones that I led, we made it right to the final selection. It's a mission. It's called Da Vinci. It's actually one of the Venus missions. It didn't get selected. And then that's when I went to headquarters. And so my colleague that I had worked with for quite a long time, he took it forward and just built on it and made it better. And then it got selected the next time around. So
amazing.
Just keep trying. Don't give up.
Love that. And I would say when you're dealing with these teams, did everybody kind of have that same consensus of just keep trying, it's fine, this is how it goes? Or were there people that would get super frustrated and bent out of shape about it?
There are, I suppose, a few, but I think most people really understood that, we just keep trying and we keep making it better. Yeah. The teams that I worked with were they were all in. And then when we weren't selected, they were ready to jump in and do it again. Particularly the science community, the scientists were, they always just want to keep trying. The engineering community, they put in a lot of effort. A lot of times if it didn't get selected, they might go on and go work on a different project. But I think they're all, again, incredibly proud of the work that we did and the teamwork that it takes to achieve even just the proposal itself.
Well, it seems like that process also pressure tests the project in a great way that probably lets the best projects come out and what we invest money into.
That's absolutely true. In fact, that's part of the review process is making sure the team can actually function under pressure.
Yeah, fair. Got it. And so how did things progress from there?
So from there, as I said, I was working on a whole bunch of these mission concepts, several different Venus mission concepts that I was involved with, none of which got selected. So after one of those rounds of mission selections, the associate administrator for science at NASA headquarters, who was Thomas Zurbuchen at the time, after my mission wasn't selected, he called me on the phone one night and he says, would you be interested in coming downtown and stepping in as the director for all of planetary science for all of NASA? The current director is taking another job as the chief scientist. He's leaving in 2 weeks. I need someone to step in right now.
Wow.
And I said, can I think about this for a minute? He says, you have 24 hours. So I knew I enjoyed working on the science. I knew I've been involved in kind of line management, managing other people. I had done it at my own company and then at Goddard. And I enjoyed that aspect of enabling the science for my other colleagues. But I had never envisioned myself as going to NASA headquarters.
Yeah.
Certainly never envisioned myself as a division director. So I had to really kind of think about that and come to grips with it. But I called him back the next day and said yes. And that kind of set me on my course at headquarters.
There's something to be said. There's not many people that can make a decision like that quickly. Like how are you able to weigh the pros and cons that quickly and just go, I'm in and just jump in?
It kind of, again, goes back to, I have many times now in my career taken these kind of jumps to, kind of, I don't know if it's a lateral jump or a parallel jump or kind of, on echelon jump, right? That, again, trying to put myself into out of my comfort zone and learn something new. And every single time I've done that, I've felt kind of like I was a fish out of water, that I was kind of, not really sure what was going on. And I always learned something new and I've always gained from it and found that to be successful. So even though it's a little scary to make that kind of a decision, I knew I'd been successful with that kind of decision in the past. And so was willing to trust myself. I also called several of my colleagues that I work with that have been at NASA headquarters and in similar roles. And every one of them unanimously said, you should go, do it, take it and go.
Yeah.
And so I got an incredible amount of support when I went to my management at Goddard and mentioned it to them. They also were incredibly supportive. And so that really gave me comfort that it was the right decision.
Awesome. And did you have to relocate for that, or did you get to stay?
Fortunately, NASA Goddard is right outside of DC. Now I have to work in Washington, DC, but I didn't have to relocate.
And what year was that you got pulled over there?
That was in 2018.
Okay, so pretty recent. And I know you had a lot of experience, obviously, looking at Venus, and I'm sure had looked at the other planets, but did you have a lot of broad planet experience before stepping into that?
Again, as coming from my background as interested in volcanoes, volcanology, I was mostly knowledgeable of what we call the rocky planets, the terrestrial planets, Mars, Venus, Mercury, the Moon, and less knowledgeable about the big gas planets, Jupiter and Saturn, or the ice giants, Uranus and Neptune, or asteroids across the solar system. So I had a lot of learning to do there. But again, kind of with a broad perspective of how our solar system works and being involved in the science community for a couple of decades, I had a lot to learn, but had also an incredible team to help me learn when I came to headquarters. So it was a lot of fun. I've enjoyed learning everything.
Yeah. How have the past 6 years been there? Tell me about how was that experience going into the thing you had worked with for so long, but then becoming a leader there?
The science leadership team at NASA headquarters is one of the most amazing groups of people I've worked with. That part was really fantastic, working with the other science leaders that were leading the other big science themes at NASA for astrophysics, understanding the universe, heliophysics, understanding our sun and earth science. Working with those leaders was an amazing experience. As I said, I really get a lot of fulfillment out of enabling others to do their work. And so being a division director really provided a lot of opportunity for enabling the entire science community, planetary science community, to do the science they wanted to do, to support the robotic missions that were helping to get the data that they needed, a lot of interacting with the planetary science community, and I enjoyed all of that. It was wonderful.
Love it. And what was a surprising difficult part? What was different about when you stepped in that you didn't expect?
The pace at which things move at NASA headquarters was just off the charts. That was nothing I'd ever experienced before. How fast decisions were made, how fast things were actually, information's needed, the information flow. That was a challenge. We talk about time management or energy management, as I like to call it, and then just the degree to which headquarters is really the one kind of driving the whole budget conversation, working with the administration. We all work as NASA employees. We work for the president, so working through that office to get support for the things and initiatives that we wanted to do, and then trying to secure the funding through Congress and keeping Congress happy with what we're doing. All of that, I knew it was part of the job, but it wasn't really in my wheelhouse. So something I had to do a lot of learning about.
And how big are those shifts? Obviously, we have some elections every 2 years, another presidential election every 4. How, you've been through Trump, then Biden, now soon to be Trump again. How are there huge shifts that happen on the space side, or is that it's not very politicized, thankfully?
Yeah, they can be, and they have been in the past. We were pretty fortunate in my transition that I was here. I came in after Trump came in, but right at the same time as the new administrator that Trump appointed. And so that was really, I think, a pretty smooth. That was very smooth as far as trying to maintain balance within science, and again, cross science and human exploration. And then when Biden came in, there was a concern that there might be some big shifts. But again, that one was fairly smooth and stable across within the science programs. And then again, now in my most recent role, looking at the human exploration side, consistent, both Trump and Biden supported the human exploration Artemis program that had been established. And so that's been pretty consistent for the time I've been at headquarters. It wasn't like that earlier in my career. I definitely experienced some of those big swings, but it's been nice since I've been at headquarters so far.
And so let's talk about the focus now, the Artemis program, and would love to hear more about what you're focusing on.
Yeah, so I'll just kind of cap off the career path, which is kind of an interesting twist, again, with this idea of something that's related, but let's kind of stretch into an area that's not in my comfort zone. I had an opportunity several months ago to step into my current role, which is the Deputy Associate Administrator for Exploration, which is really, in plain language, the number 2 person in charge of making sure that we can get astronauts on the moon and Mars coming up. So through the Artemis program. And so I don't have a background in human exploration, but the agency is really focused right now on making sure that the Artemis program is really enabling science on the moon, and then ultimately enabling more science at Mars using human explorers. And it's really, in my mind, the first time the agencies really worked together between the science and the human exploration side of the house this closely. And so I was really excited by seeing this amazing progress between human exploration and science, and the fact that they even would consider a scientist to come into the human exploration side as a associate administrator. I thought this is a great time to step in and try and work to enable more science again through human exploration. So Artemis is an amazing program. We've already launched the first test flight of the first rocket, Artemis 1, 2 years ago, a little over 2 years ago. And we're working now towards the second Artemis flight, which will be the first flight with crew. There'll be 4 crew on the next Artemis flight. It's right now scheduled for a year from April. So April of 2026. That flight's going to fly the astronauts around the moon and bring them back to Earth. And then the next flight is the one where we are, hoping to land on the moon.
Got it. And is there any partnership with that with JPL or SpaceX?
Yeah, it's a great question. One of the big differences in how we're executing this time around is we really are working to enable more partnerships with commercial companies. The rocket and the space capsule that we're using for the first 2 Artemis flights are kind of more with our traditional industry partners. But the landers that we've contracted for to land on the moon, we have 2 of those human landers. One's provided by SpaceX, and that's the Starship that'll be landing our astronauts on the moon for Artemis 3 and 4. And then Blue Origin has the contract to do the lander for Artemis 5. Wow. So we are working with those commercial companies. It's a very different kind of partnership because it's basically their intellectual property. It's their rockets. They're responsible for the development program, and we pay them when they achieve certain milestones. But it's really exciting to be working with the commercial.
No, I've got to imagine. I mean, they're just, again, as you say, pace. Like I've got to imagine the pace is a little different because they're doing this to make money too, which can be good and bad. That's awesome. And so, a couple more questions for you. Number one, I guess I always ask what's next, but it sounds like getting some people on the moon and Mars is what's next.
That is absolutely what's next. We're so focused right now on achieving those milestones. We absolutely want to get to those. The first woman and the first person of color on the surface of the moon, first international partner on the surface of the moon. We are working towards that. We're gonna get there.
The only country that's landed on the moon
with astronauts. That's correct.
Astronauts. Yeah, that's what I mean. Yeah. Wow, didn't realize that. And that happened was that 69 or 67?
69.
69. Yeah. Wow. That's crazy. And then last question, for someone trying to get to the pinnacle of their career, achieve their dreams, go after it, what would be one thing you heard or wish you heard, or one piece of advice you'd have for someone?
The biggest piece of advice is probably trust yourself. We all talk about this inferiority complex or whatever the other words are for that, right? That you feel like imposter syndrome, right? And I think we all experience that at certain points in our careers. And the thing that has really astounded me that, I felt that my whole life. And then when people started talking about it, it turns out everybody feels that. And I really wish that more people would have talked about that and said, look, it's totally normal for you to feel like you're out of place. And, it's okay. Trust yourself, trust what you know, and trust that you can do what you want to do.
Love it. Well, Lori, this has been amazing. Good luck, because I really hope that we continue to explore space. And thank you so much for coming on Hawk Talk.
It's been my pleasure. Thank you.